Hi everyone, it's Miss Costa here, and in this video I'm going to be going through bearings that have trigonometry or angles or are just a little bit more complicated. Okay, so here I'm being asked to work out the bearing of A from C. So remember, we always start wherever it tells us from and we work clockwise. So I'm going to need all of this angle here until I reach a line. So I know that this is a circle. So therefore I can do 124 plus 94. Oh, why does it always go really large? So 124 plus 94 is 218. And 360, take 218. Oh, I'm just using a calculator for speed, is 142. So this angle here is 142. Now I am going to need all of this to get from A from C, because I need to go all this way here. So I'm going to do 94 plus 142, and that gives me 236. So that is the bearing of that. Next, I've got the bearing of A from C is, so the bearing of A from C, this whole thing is 260 degrees. The bearing of B from C is 95 degrees. So just this little bit here is going to be, oh, and that should be 0.95. Work out the size of angle ACB. Okay, so what I'm being asked to do is work out this angle here, angle ACB. Remember, when you have an angle, you use the middle letter to find like the point at which the angle is, and then it's in between the other 2 points. So angle ACB is this angle here. I know that this whole thing is 260, and I know that that angle there is 95, so I could just do 260 take 95, which gives me 165 degrees. So let's have a go at doing those by yourselves. So pause the video. Okay, so here I need to work out the bearing of A from C. So once again, I need all of this over here. Now this is a circle, it's angles at a point. So I know that 360, take 44, take 87 is 229. So this angle here is going to be 229 degrees. And the bearing of A from C is all of this part here. So I do 229 plus 44, which is 273 degrees. And over here, I've got the bearing of A from X is 290. So this is 290 degrees. And once again, this should be 050. The bearing of B from X, so let's do a different colour, is 50 degrees. So that's 50. Work out the size of angle AXB. So the angle I want to work out is all of this bit here. Okay, so how can I do that? Well, first of all, I know that all of that angle is 290 degrees. So what I could do is 290 take 50, which is 240 degrees, so that I just work out this bottom angle here. So I know that this angle here must be 240. Okay, and then I know that angle is in at a point, sum to 360. So I do 360, take 240, take 50, take 240, take 50 is 70. So this angle here must be 70. Now I want to work out angle AXB, so this whole thing here. And that would be 70 plus 50, which is 120 degrees. And that's how you do that. So next we've got a little bit of a little bit more of angle rules, a little bit trickier. So shown as a diagram, y is due south of x, which means they're on a parallel line, and xz is xy. So this is important because it means that we are dealing with an isosceles triangle. What that means is it has 2 equal sides and 2 equal base angles. So this angle here and this angle here are going to be equal. So let's see what I can do. I need to work out the bearing of Z from Y. Okay, so this is the angle I need to work out. Okay, so once again, I'm dealing with angles on parallel lines. So I know that if this is 52 degrees, this angle here must also be 52 degrees, because on parallel lines, if you have alternate angles, they are equal. So alternate angles are equal. I could also sorry, have used the interior angles. So I could have said that's 180, take 52, which is 128, and then this is a straight line here. But if you know the alternate angle rule, which if you don't, then watch the video on angles in parallel lines and the rules. So if that angle there is 52 degrees, then I know that my base angles must be 180 take away 52 divided by 2, because there's 2 of them. So 180 take 52 is going to give me 128. So these 2 angles must add up to 128. So to find one of them, I'd divide by 2. And 128 divided by 2 is 64 degrees. So this angle here is 64 degrees. So the bearing of Z from Y, I start from Y, due north until I hit the line, is going to be 0, 6, 4. And that's how I do that. Okay, so here I've got a right angle triangle included in my bearings question, which generally means you're going to use Pythagoras or trigonometry. So first thing we do is identify what we're trying to do. So the distance of M is 120, it's 80 kilometers due east, and I need to work out the bearing of M from N. So I start from N and I work out everything until I get to the line connecting M to N. Now, a common mistake might be that you just do it to the base of the triangle. You always have to go to the line that connects the two. So it's all of this. So obviously this bit here is going to be 270 degrees because that's a right angle, but I need to work out the angle X as well. So I've got my triangle. I need to work out an angle, so it's going to be trigonometry. The first thing I do is label the triangle, and everything is in relation to the angle I've been given. So this is the angle, so this is going to be the adjacent side. The hypotenuse is always the side opposite the right angle, and this is the opposite side. So the 2 sides I'm dealing with are the adjacent, which is 80, and the hypotenuse, which is 120. So my trigonometric ratios are SOHCAHTOA. And the sides have been given are A and H, so I'm going to use CA. So I'd write out cos theta is adjacent, which is 80 over 120. And to work out theta just means the angle. It's a sign given in maths to the angle. So I'm going to type in, because I'm working out an angle and I can't divide by cos technically on the calculator, I do the inverse of cos, which is shift cos on your calculator, and then you type in the fraction 80 over 120. And that gives me 48.189681. So that is angle X. Angle X is 48.189, so forth. So the bearing of M from N is going to be this part here, which must be 270 degrees because you know, northwest and all of that, that's at 90, that's at 90, that's at 90, plus what I've just worked out. So 270 plus 48 point blah 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 is going to be 300, and let's write this in a different color, 318.1896851, and it's asked to give it to the nearest degree, so that would be 318 point, nearest degree would be 18, so 318 degrees. You don't need to round it because it's nearest degree, not decimal. Okay, so let's have a go at 2 of similar questions on your own. So press pause. Okay, so for the first one, we've got the same things. N is 50 kilometers due, it should say due east. But let's just get on with that. So work out the bearing of M from N. So once again, we want to work out all of this part here. We know because this is meeting at north and west that this bit here is going to be 270. So we need to work out X as well. Trigonometry, so we're going to label our triangle again. We've got the adjacent and the hypotenuse, so we're going to use cos. So cos theta is adjacent 50 over 90. So theta would be, let's type shift cos 50 over 90 is 56.251014. So x is 56.2 and the whole angle will be 270 plus that, which is 326.251, but it's to the nearest degree, so I'm going to say 326 degrees. Remember, bearings are always written as 3 figures, hence why it says to the nearest degree. Okay, and then the next question, we have a diagram. Y is due south of x, xz is xy, which means it's an isosceles, and I need to work out the bearing of z from y, so this angle here. Okay, so use your knowledge of parallel lines. So this angle here and this angle here are going to be alternate angles, and therefore they are going to be equal. So that's 48 degrees. It's an isosceles triangle, which means that the base angles, I'll do it in a different colour, the base angles are equal. So 180 take 48 is going to give you 132. So these two angles here must add to make 132. So we divide by 2 because they're equal. So each of these angles is 66 degrees. So what is the bearing of that? I'm just checking if I did it the whole thing. Yeah. So the bearing of Z from Y, start from north, go to the line, that's going to be 066 degrees. So hopefully that was helpful, and let me know if you need anything else.